Therefore, substituting AK1 dagger and AK2 dagger in the combinations for J. कौन सा वाला ये वाली इक्वेशन दिस इक्वेशन या सो इस इक्वेशन के अंदर इस इक्वेशन के अंदर अगर हम इसकी वैल्यू इधर वैल्यू और ये वैल्यूज और ये वैल्यू सब्स्टिट्यूट कर दें तो देन वी व्हाट वी वुड हैव a simpler equation. Therefore J becomes J, which is equals to summation over K times H bar K times half ब्रैकेट में ए के प्लस सिंप्लीफाई भी कर रहे हैं ए के प्लस डैगर प्लस ए के प्लस डैगर और ए के प्लस प्लस माइनस वाली टर्म्स ए के माइनस एंड ए के माइनस डैगर एंड प्लस ए के minus dagger and AK minus. So we have these four terms. और अगर हम बेसिक कम्यूटेटर आइडेंटिटी विच इज इक्वल टू 1 इस्तेमाल करते हुए इसको सिंप्लीफाई करें तो J जो है वो हमारे पास आ जाएगा समीशन ओवर K H बार K टू हाफ जो है वो अंदर एब्जॉर्ब हो जाएगा बिकॉज देन वी वुड बी यूजिंग ए कॉमा ए डैगर प्रॉपर्टी कम्यूटेटर ऑफ ए एंड ए डैगर विच इज इक्वल टू 1 और वो प्रॉपर्टी इस्तेमाल करने पर हमारे पास जो फैक्टर्स आएंगे दैट वुड बी ए के प्लस डैगर ए के प्लस एंड प्लस और रादर माइनस इन फैक्ट बिकॉज जब हम प्रॉपर्टी इस्तेमाल करेंगे ए एंड ए डैगर के दरमियान कम्यूटेटर तो दैट इज इक्वल्स टू ए डैगर माइनस ए डैगर ए इक्वल्स टू 1 और देन आपके पास ये वैल्यूज जो कुछ उसमें से कैंसिल आउट हो जाएंगे एंड सो दैट वुड बी हियर वी वुड हैव अ माइनस साइन हियर so we would have a minus a k minus dagger or a k minus without dagger bracket close. So we have two new operators. एक को हम नाम देते हैं एन के प्लस और एक को एन के माइनस एच बार के then we would have n k plus minus n k minus number operator where we have these two new operators that is two new number operators और वो क्या हो जाएंगे दैट इज एक है एन के प्लस विच इज इक्वल्स टू ए के प्लस डैगर ए के प्लस और दूसरा है एन के माइनस विच इज इक्वल्स टू ए के माइनस डैगर और ए के माइनस या so what are these obviously ये a k plus and a k minus dagger they create photons but they create photons with plus or minus helicity yeah that is right circular and left circular polarization अगर मैं right को plus से जाहिर करूँ और left को minus से जाहिर करूँ ठीक है so इसका मतलब हो गया obviously a k plus dagger and AK minus dagger they both क्योंकि dagger लगा हुआ है create photons photons with plus or minus helicity or minus helicity. Yeah, that is component of angular momentum either parallel or anti-parallel anti-parallel to k. That is the propagation direction to k. That is basically so one can fairly easily calculate or express A, E, B as well using these creation operators for such defined helicity. That is for such plus helicity and minus helicity. So one can easily express A, E, and B as well using using these creation operators for a defined helicity, that is plus helicity or minus helicity. ओके सो दीज एक्सप्रेशंस जो हमने ऊपर लिखे हैं ये एक्सप्रेशंस एप्सिलॉन के लिए भी उतनी ही वैलिड हैं जितना ये ए के लिए वैलिड हैं एंड वी कुड राइट such expressions for epsilon k plus and epsilon k minus using epsilon k1 and epsilon k2 उसी तरह से जैसे हमने ए के प्लस और ए के माइनस की एक्सप्रेशंस लिखी थी सो द एक्सप्रेशंस expressions such as summation over k or lambda rather or k lambda both rather so that would be epsilon k lambda and a k lambda and इसी तरह की और सारी expressions they work whether lambda refers to linear or circular polarization linear or circular polarization basis और तो ये किस तरह से किया जा सकता है दैट सिमिलर टाइप ऑफ रिलेशन हम के प्लस एप्सिलॉन के प्लस के लिए भी लिख सकते हैं एंड दैट वुड बी इक्वल्स टू 1/√2 with a minus sign here and epsilon k1 plus iota epsilon k2 उसी तरह से जैसे हमने उसके लिए लिखा था एंड सिमिलरली फॉर epsilon k minus that would be equals to 1/√2 and that would be epsilon k1 minus iota epsilon k2 and so on yeah so उसी तरह की हम रिलेशनशिप्स लिख रहे हैं जैसे हमने ए के लिए लिखी थी ठीक है एंड ऑब्वियसली दीज आर सिमिलर सो हम इससे क्या कंक्लूड करते हैं हम ये कंक्लूड कर सकते हैं कि the EM field है it does carry a quantized angular momentum यानी photons have an intrinsic angular or photons have an intrinsic spin of magnitude h bar. Yeah. So ये कॉन्सेप्ट जो स्पिन का फोटॉन्स के साथ अटैच कर रहा है यहाँ से इट इज वेरी वेल प्रूव. So we conclude that EM field does carry quantized intrinsic angular momentum, i.e., that is, photons have an intrinsic spin, have an intrinsic spin of magnitude h bar. H bar. And because we talk about an intrinsic property of photon, then it would generate it would be generated in some state. Let's say if vacuum the state and we apply on the vacuum state AK plus dagger, then a photon would be created in that state with positive helicity. Yeah. So which is sort of generated in the state that is कैसे. So if a k plus dagger x on vacuum, that would create a photon uh, of plus helicity is created. Yeah. So photon is one could think about photon um, somewhat in a vague manner because think about photon as being something vaguely something that if AK1 dagger operates on vacuum, then one photon state would be generated. But one could consider a superposition of positive and negative helicity of photon states, जैसा कि हमने डिस्कस किया था when we were doing identical particles. So this is something which is very important to note. So we note here that a photon is somewhat vaguely defined. Vaguely defined because because AK1 acting on this vacuum also is a one photon state, but could be could be considered a superposition of positive and negative helicity and and negative helicity photon states. Yeah, so in quantum mechanics, we are basically used to of writing linear superposition. That is basically some basic characteristic of quantum mechanics. uh, that whenever you write a state, that state is a linear combination of the basis state, which is basically some defining statement of quantum mechanics. And so one could define in that same manner that one photon state would be a linear combination of positive and negative helicity state. So one could think about as a k1 dagger acting on 0 as a linear combination of positive and negative helicity basis states. So this is something which is important. Okay, so let's now start the interaction of electromagnetic field with matter. Uh, you know the So what we have done is quantization हम कर चुके. Now जो दूसरा बहुत important part है, that would be the interaction part. That is the EM field interacts with charged particles. Uh, uh, so uh, so let's say we start with the interaction of electromagnetic field, which is a very interesting topic. मजा आएगा आपको, because इसमें हम ये देखेंगे कि how the EM field interacts or couples with a charged particle. And we would also sort of consider, and in this particular case, we will consider a non-relativistic particles, because considering relativistic effects would make the treatment much more complex. And we consider that the EM field is composed of photons, that is, which are quantized in nature, and they are only weakly affected by the presence of moving charge particles. So these are some sort of simplifying assumption for the treatment. So let's start the interaction of EM field. Hmm. So the EM uh, field couples to charge particles. We here consider coupling to be non-relativistic, coupling to non-relativistic particles. So assumptions हम क्या ले रहे हैं? Assumptions हम ले रहे हैं EM field couples uh, to non-relativistic particles. एक बात. दूसरी बात हम ये कर रहे हैं, we consider the EM field is composed of photons. EM field is composed of photons which are quantized. And तीसरी बात, uh, we consider only weakly affected by the presence of moving charge particles. EM field is weakly affected by moving charge particles. बिकॉज देन फिर हमें हमें अगर हम ये करेंगे तो फिर हमें बुनियादी तौर पर अपने हैमिल्टोनियन के अंदर उस इंटरेक्शन को भी इंक्लूड करना पड़ेगा विच इज़ ड्यू टू दी motion of charge particle, and that motion of charge particle would generate some sort of field, and that field would also be interacting with the EM field. सो बुनियादी तौर पर इसका मकसद ये होगा कि सो वी आर यूजिंग दी perturbative approach. So a perturbative approach can be applied. Can be applied. So here we are, since we are talking about weak interaction, so a perturbative approach can be used in this case. Uh, Now we can use the usual prescription to include EM field within the with the replacement of P to some other variable. That is, we do some sort of a gauge transformation. So uh, using a usual sort of method or prescription to include EM field with the replacement. कैसे? P would change to uh, P minus Q upon C into A vector, where Q is the charge जो कि कपल हो रहा है, और हम उसको बुनियादी तौर पर Q को माइनस ई भी लेते हैं. जैसे इलेक्ट्रॉन, अगर हम इलेक्ट्रॉन की बात करेंगे तो दैट वुड बी द इलेक्ट्रॉनिक चार्ज. एंड सिमिलरली ई जो है that would change to E minus Q times A naught. So one is vector and the other one is a scalar. So where we can say where Q is the charge coupled to coupled to EM field, and can be electron charge, meaning Q would be equals to minus C, where A naught जो है, where A naught is the scalar potential जिसको हम आमतौर पर phi से ज़ाहिर करते हैं, is the electrostatic potential. And for free radiation, phi जो होगा वो किसके बराबर होगा? 0 के बराबर होगा. But this is, although we are taking for free radiation phi 0, but this is not true for all cases. Yeah. Here E is the energy, so energy operator इस्तेमाल करेंगे. So here E is the energy, therefore E is equals to iota h bar partial derivative with respect to time, और इसको हम यूं भी लिख सकते हैं iota h bar partial derivative t, d by dt को dt से भी ज़ाहिर किया जा सकता है. And momentum and P is the momentum, और momentum को momentum operator corresponding to operator P, which is equals to minus iota h bar del. और अगर हम इन दोनों को मिला लें तो वी वुड हैव अ फोर वेक्टर टेकन टेकन टुगेदर, that is E upon C, and P forms a four vector. This is some four vector. And so both are affected when EM field are present, and so both are affected when EM field uh, is present. So, what we consider sort of an original problem of non-relativistic particles moving in some potential V of R. Yeah, and according to so if you are using the Schrödinger equation, then you know the Schrödinger equation is something at psi. The Hamiltonian acting on psi is equals to the energy eigenvalue E times psi. And in this case, the Hamiltonian would contain some terms. One of the term would be the kinetic energy term, and the other term would be the potential energy term. So to start with, we write the Schrödinger equation in its most basic form, and then we change P and E as we have done in changing these variable in this case. That is, P changed to P minus Q upon Ca, and E changed to E minus Q into A naught. So we consider some sort of original problem of non-relativistic particles moving in some potential VR. So we consider uh, an original problem of a non-relativistic particle, of a non-relativistic particle moving in some particle moving in some some potential V of R. Yeah, and according to Schrödinger equation, the IE H operator, let's say मैं इसको सबस्क्रिप्ट A कर दूं, acting on psi is E psi. This is the fundamental form of the Schrödinger equation with the Hamiltonian HA, which is equals to किसके बराबर, P square upon 2m plus V of R. This is basically the basic equation. So therefore the equation क्या हो जाएगी, that would be P square upon 2m plus V of R. This is the Schrödinger operator acting on psi is equals to, where psi is a function of R and T. Here psi is a function of R comma T, both position and space, and this is equals to iota h bar d by dt psi of R comma T. That is the time dependent form. Now let's say we we turn on the EM field, or EM field agar we turn, then we need to replace P and E by the replacement what we have done earlier. So now turning on the EM field, on the EM field, this would become P की जगह लिखेंगे तो that would change to P minus Q over C into A whole square divided by 2m plus V of R as it is plus Q A naught, uh, that is basically coming from the E part, and this whole sorry, Q into A naught is the potential psi of R comma T, which is equals to iota H bar d by dt into psi of R comma T. Yeah. So we have this in new equation, that is we would think about this equation as it is gauge invariant. Why gauge invariant? Because we are using transformation from P to P minus Q upon C into A and E to E minus Q into A naught. Yeah. So this represents some sort of a gauge invariance. Yeah. So since we use effectively H is equals to this factor, this Hamiltonian, uh, whenever the EM field is present. So whenever there is an EM field, the Hamiltonian which we would be using is the one which is given in this equation. So uh, since we use effectively H is equals to P minus the vector Q upon C into A whole square upon 2m plus V of R plus Q into A naught. Cup whenever when EM field is present. That is, its effective effect would only be true if the EM field is present. Yeah. Uh, we also make some short comments here about the choice of A and A naught to represent some sort of field E and B, and this choice of A and A naught to represent some field E and B is not unique. So it means if it is not unique, then we need to have some sort of a gauge transformation, जिसको हम बुनियादी तौर पर गेज रिप्रेजेंटेशन या EM गेज ट्रांसफॉर्मेशन कहते हैं. So this is important that when you are using some sort of a gauge, that is a vector potential A naught as electrostatic scalar potential, and you represent you use these vector potential and scalar potential to represent E field and the B field, electric field and the magnetic field, then this representation is not unique. That is, there could be more than one pairs of A and A naught to represent same E and B, and this is what we mean that it is not unique. Yeah. So we can say a comment here. The choice of a vector in a vector potential and scalar potential A naught to represent some fields given by E and B is not unique. Is not unique. That is, our choice of A and A naught is unique for some E and B. So there could be many pairs of A vector and A naught for same E field and D field. Yeah. So different choices of A and A naught can be related by EM gauge transformation, and that corresponds to the same E of R unless and until we use some sort of a transformation. Yeah. So we could think about different choices, choices of A and A naught related by EM transformation, EM gauge transformation, transformations corresponding to the same to the same E of R comma T field and B of R comma T field. But cup, but they will they will produce will produce different quantum wave functions. Why? Because we have, uh, in fact, uh, there is no uniqueness there. Different quantum wave functions, psi of R comma T. If the if the EM gauge transformation, EM gauge transformation, वो अगर कुछ इस तरह से, that is we change the vector potential to A prime, which is equals to A plus uh, gradient of some function lambda, capital lambda, and scalar potential A naught to